I'm going to solve profit optimization, the bread. So for given plain bread is XLU. XLU, and then sweetie bread is Y value. Y value. So the function is so to locate such a point, you must find first derivative partial. So how to find first derivative partial? So if you find first derivative partial, you just looking at who have x variable. If you see variable y or this number, you just input 0. Like this, 2 times 2 minus 4, and then 2 minus 1 is 1. And then this is half variable y, you just input 0. And then this is 1, and then 1 times 4 is 4. And then 1 minus 1 is 0. So this is half variable y, and you just input 0. So this one is y, and then the only number you just input 0. And don't forget, set them to 0. To 0. So next, first derivative partial y. If you find first derivative partial y, you just look at half variable y. If you see variable x, you just input 0. Like this, input 0. And then this 1 times 3 is minus 3. And 1 minus 1 is 0. And then there's a half y. So we just input 0. So this 1 times 6, and then 1 minus 1, only 6. So this only number, and don't forget set them to 0. Oh, I'm sorry. So this function have this. So 2 times minus 3, so minus 6. Minus 6, and then 2 minus 1 is y. So this is equation 1. So this is equation 2. So now we have equation 1 and then equation 2. So look at equation 1, we can express as y. We can find y value. So this y value so now we have y value. So for find x value, we can y value substitute to equation 2 for find x value. So we can input from there. Minus 6, this is y value. Minus 4 plus 4x, and then plus 6 plus x equals 0. So we can move. So we can times like this, and then like this. Minus 6 times minus 4 is 24. And then minus 24x. And then plus 6. And then plus x equals 0. So we we can move. So 24 plus 6 is 30, and then 25 minus x is 23, so x 30 divided 23. So this is for fraction. So for decimal, wait. So this is fraction x value. So new function for find y value. So y equal minus 4 plus 4x. Why use fraction? Because avoid rounding error. If it decimal, we can error calculate. For step, we can use fraction. So 93 divided 23. So y is 28 divided 23. So this is for value, y value, and this is for x value. So we have stationary point. So next step. So next steps, Hessian matrix. The test with Hessian matrix to analyze curve function and verify the stationary point rule. So this one, in first derivative. So this is first derivative. Because if I move to second derivative, you can confuse how to find second derivative partial. So I write first derivative again. So this is for the first derivative partial. So we want to Hessian matrix using second derivative partial. Next step, Hessian matrix using second derivative. So this is second derivative. So this you just look at zero at x variable. So this 1 times minus 4 is minus 4 because if this is heaven number, it is 1, like 1. So this is 1 minus 1, it's 0. So don't use x for this. And then if y and if variable y and then only number doesn't have x variable, you just input 0. So that's it. So next. Okay, you just focus who have variable y like this. So yep, only minus 6. This is 0 and this is 0 because this doesn't have variable y. And then so the x and the y is 1. So after that we have second derivative. So next continue. Okay, next with formula Hessian matrix. Hessian matrix formula. So this is second derivative partial x, and then this is and then this is so this is second derivative partial y. So we just input the data to this. So this is second derivative partial, minus 4, and then input this, minus 4, and then 1, you just take 1, and then this is 1, 2, and then second derivative y, minus 6, and then this input minus 6. So after that, we determine calculation. So you just data from there. So you just like this and this, yep. Times minus 4 times 6, and then minus 1 times minus 1, like this. So minus 4 minus 6, and then this and this is minus, okay, minus. So minus 1 times 1, okay. So 6 is minus 24. Oh, I'm forget. This is minus. This is minus 6. Let me see. It's minus 5 times minus 6 minus, minus, so positive. So positives. 1 times 1 is 1. 24 minus 1 equal, so 23. So determinant 23. So if the determinant is bigger than 0, so the stationary point is the local maximum. So this is the stationary point is local maximum. So this is the local maximum. And then from second derivative partial, if second derivative partial smaller 0, so that is max. So first derivative partial is minus 4, and minus 4 smaller 0, so that is max. So if this and this, so this is max. So max. And then after that, we have x value and then y value, so substitute to original function. So original function, is so we substitute x value and y value to the original function, okay? So wait, recommend x is d divided 10p, and then y is 28 divided 22. So wait. For 1.30, and then for y 28 divided 23 equal 1.22. So substitute x and y value to the original function, minus 2. So for original function, we input fraction because avoid rounding error for the calculate. So this minus 3, and then 28 divided 23, so 2, and then plus 4, 30 divided 23, and then so and then 6, 28 divided 23, and then x and y as 30 divided 23, so y 28 divided 23, so minus 10. So and then calculate divided 529. So this is the fraction, and then the decimal is 3.74. So the minus. So this is minus. For minimize the loss function, the bread should producing the plain bread is x value 1.30, and then the sweetie bread is y value 1.22, and the absolute loss function is 3.74. So it's all. Thank you for attention.
Good afternoon, everyone. My name is Syifa Aulia. So I'll explain for number 3 that have you ever, when you pay something, like there's something you want to pay but you have a limited budget. So here's the things how we achieve our maximum utility in our minimal budget. So the function maximum here is u x y x y, and the price for x is 4, price for y is 2. So we got the constraint equation is 4x plus 2x equal 40. So here we have the price x is 4 here, so the price weight is 2 here, but our budget is 20. So the first thing we solve is use Lagrange method. So the Lagrange function is x, y, lambda over So the first thing we find the first derivative. The first derivative respect to x. We just derivative respect to y is y minus 4. Then respect to y is x plus 0 min 0 min. So the derivative respect to y is x minus 2. Then respect to lambda 0 40 minus 48 minus 2y. So the first derivative from lambda is 40 for x min 40 min for x and min 2y. Then after we know the first derivative, we set them equal with 0. So this is become first equation 1. Then x means 2 lambda equal with 0. Become x equal with 2 lambda. So this become equation 2. Then for t minus 4x minus 2y equal with 0, it become 2x plus 2y equal with 40. To find y that we need eliminate the lambda, so we use this eliminate. Is y that we find for h minus 2. So the equation that we find way is 2x. Then this become equation 4. I forgot this one become equation 3. So to find x, we need to substitute equation 4 into equation 8. Find x. Substitute equation 4 into equation 3. We know that equation 4 is 4x plus 2y equal to 40. Then we substitute in with equation 3. Substitute with equation 4. Then 4x plus 2x 2. Sorry, this was 2. Then we find 4x plus 4x. Then 8x 40. So we move x to here, so divide it by. Then we find x equal with 5. So we can find way. We must find way 2 using equation 3. Use equation 4. Find way. Way 2 5. Then we equal with 10. So after we find the x is 5 and y is 10, we substitute them into the utility function, to maximum utility function. Then the maximum utility function is y. so that we know dx is 5 and dy is 10. So 5 times 10 is 50. So our utility function is 50 when consumer have their maximal satisfaction of 50 by 5 with 5 unit of food X and 10 unit of food Y. They can get if they spend 40, they can get goods X 5 units and Y and goods Y 10 units. That's it, and thank you.
Hello everyone, my name is Hidayat. I will explain the fourth or the last problem that we have, which is to minimize cost function. I will write down the function first. So in this problem, it asks to minimize production costs. The factory must produce exactly 120 product. That's our constraint, okay. And the cost function is 2L quadrat plus 3K quadrat, where L is for labor and capital is for K. So I have write the equal with 0, which is 2K minus L plus 2K minus 120 is equal with 0. So I have written the second part. To minimize cost while satisfying the constraint, we use Lagrange method. I built the Lagrange method function f by adding lambda times the constraint to the cost function. Then I take the partial derivative with respect to L, which is labor, and for capital is K, setting both equal to 0. This gives me the equation 1 for this. Lambda is equal with minus 4L, and the second equation is lambda is equal with minus 3K. Both are equal to lambda. Since both are equal to lambda, I will set the equal with each other, which is minus 4L minus 3K 4L is equal with 3K. So K is 4L3 minus 4L equal minus 3K. Simplifying this give K equal 4L over 3. This is the optimal ratio between capital and labor. the fourth part, I substitute decay equal for L over 3 back into the constraint because we still need to produce exactly 120 units. So for L is 360 over 11, which gives us 332.73. Using the same ratio, K equal 480 over 11, which gives us approximately 43.64. Next to the, we move to the next part. Okay, for the last step, finally, I plug in back the L and K function to the total cost, which is total cost equal to times L square times K, which give us the approximately of 7,855.37. So the lowest cost combination to produce 120 units is for the labor is 32.73. For the capital is 43.64. And lastly, for the total cost minimum total is 7,155.37. So that is it from us. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Athalla. Now I will solve the problem about the linear matrix. So first of all, write the question first. Equals 40. Then second is 1x1 plus 3x2 and then 1x3. 1x3 also. Then equals 16. Next is 1x1 1x2 plus 1x2 plus 4x3. 4x3 equals 20. Okay, let's jump to the formula. First of all, let's write the coefficient like this: 2, 1, 1, 3. 1, 1, 1, 4. X1, X2, X3 equals 14, 16, 20. So this is A. Forget A equals is it the coefficient? So calculate the determinant of matrix A. First of all, I will call factor C11. Then A equals 2 times C11 minus 1 times C12 plus 1 like C13. Alright. So of number 4, C11 equals 3, 1, 1, 4. So we do the x multiple like this with this and then this. So the result is 11 and then C12 is 1, 1, 1, 4. The result is 3. Then C13 is 1, 3, 1, 1. So the result is minus 2. Minus 2. Okay. We have to multiply first. 1 times 1, and then we have to minus it. This one, forever. 3 times 4 is 12. 12, and 1 times 1 is 1. So equals is 11, and then same as the first option. Next. And then conclusion that solving the system using Cramer's rules. This is the A1. We put the x first, like the 14, 16, and then the 20 into the first column at the A1 coefficient, like 14 and then 16 and 20, and then 1, 1, 3, 1, 1, 3, 1, 1, 4. We have to make like this. This is the first, like the x1, x2, x3. So we input the x1, x2, x3 into this A1, and then let's calculate it using the same formula. There, A like this, and then A1. Don't forget the 1. Then this is so 14. Why is 14? Because of this. It means like we block all of this. So we got the 3, 1, 1, 4. 14 like this. 3, 1, 1, 4. And then also the 1. We got this. And then 1 it equals 3, 1, 1, 4. No. 16, 1, 24. 16, 1, 24. So it means that we got the 1 plus 1. So we have to block this. And then this also. We got 16, 1, 24. 16, 1, 20, and 4. Like this. And then the last one also 1. The last one is here. So we have to change the block is to here. And then we got 16, 3, 21. 16, 3, 20, and 1. We have this data. So we have to calculate it. Same like the first one, we have to multiply x multiple and this and then minus. So we have the result is here is 11 and then 44, and then the last one is minus 44. This is, we have to do this 3 times. Before, first one is in the first column, and the second one in the second column, and then the last one in the third column. With the same formula, we have to block first one, and then second one, and then the third one, until we got these numbers, so we can calculate it. So for the A2 say like wait, I forgot. 2, 1, 1, and then 14, 16, 20, and 1, 1, 4. We have some form like this, 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 and this. Semi-4, and then the third one also same. We have the A3 here, same also. The difference is like 2, 1, 1, 1, 3, 1, 14 here, 16, and then the 20. So with 74 like this, we have to block the first column and the first row, and then the second column, and then the second row, also the third column, and then the third row. So let's continue. Actually, we have from the A1, we have A1 was with this formula, the A1, the third, the A1 equals 66 per 17. I think that's 17. So it means 3,882. We got this from the A1, and then we have the A2. We calculate with the same formula. So we got here the 50 per 17, and then equals 2,1941. And then the A3, we got 56. 56 per 17 equals 3,294. So let's interpreting the values in economic context. This we have got this result with this formula. So we have to calculate it. We have to like explain it carefully. Like we have to, I will make the table. Right? The first one is agriculture, and then the second one is industry. The third one is services. Then exact fraction here. Exact fraction in billion. So we have like the decimal. I mean the part one. 17, and then 50 per 17, 50 per 17, and then last one is 56 per 17. So we also get the same decimal value here. Value. The result from 66 divided by 17 and others. We have 388. Don't forget the dollars. And then this one is $2.94. And then the last one is $3.29. So this is the result from the linear matrix. So we got this. And then thank you for listening, and goodbye.